So to be able to study a lot of the questions that we are interested in studying, we need to standardize our data on occupational descriptions. So we need some way of transforming long pieces of text into a standardized occupation. And we are developing right now, and I'm going to be able to show you some results for a tool which can do that automatically instead of spending weeks and months developing and transcribing data. For now, we call it Breaking the HISCO Barrier, AI and occupational standards, data standardization, and I'll go through some details of that project with you right now. In 2023, the Nobel Prize in Economics was given to Claudia Golden for having advanced our understanding of women's labor market outcomes. And to figure out something like that, or figure out things about that, we need to know what people did. We inherently just need some kind of data on the labor market and people's jobs. So what we are working on, which relates to this, is an algorithm which can automatically classify occupations based on raw textual entries from archival data. And more than just a Nobel Prize, this is important because it's the kind of information that we need to be able to address some really, really big open questions. It's about the role of technology and change of technology. So what is going to happen when AI comes? Turns out that if we look through history, we can find examples of groundbreaking technologies at other points in time, and we can study that if we know something about what people did and know something about what's in the archival sources. We want to understand the dynamics of income and inequality, and we also need to know something about what people did for a living to be able to study that. We want to understand social mobility. We want to understand the returns to education, and so many other questions, all of which just requires a lot of data. And now here's a small illustration, and it could be an illustration of me or any other researcher within economic history, because this is a lot of what we do. We sit in archives for days and days, and we try to categorize and systematize data. And we would like to make that much easier. Here's an example of the type of data that we, in particular, are trying to do something about. So here you see some occupational descriptions from raw data. So here's a Major General RHA retired, or a Porter Labor Master, or higher executive officer of the Department of Industry, or here there's a clerk in the Holy Orders chaplain to the Honorable East India Company. Data sources are a mess. Like, for some reason, people 200 years ago were just not aware that we were going to have modern computers to analyze this type of data. So they didn't note it down in a way which is easy to analyze. So the solution to that problem is to write it down as HISCO codes instead. The HISCO system is based on an international classification system from the 60s, but adapted to fit historical occupations. And the idea is that instead of having a raw piece of text that describes what people did, we give it a standardized code somehow. And this is just a code that describes a farm servant. So the first digit says that something about him working in agriculture, and then we get more and more information, and then we get the specific code for farm servant. So it's a very nice way of categorizing things, and it's the most used way of categorizing occupations out there. Typically, this is done by painstakingly spending weeks, months, years and such, just manually reading and categorizing this type of data. So imagine millions or thousands of observations of this form, where you just have these descriptions, and then you go and look up a table of HISCO codes and then assign a HISCO code to each of these descriptions. Problem with that is that there's a lot of variation in there. So just for the Danish case, from Danish censuses, we know of 17,865 different ways of writing the occupational description that fits with farm servant. That's because there's so many small variations in how you can write that. So you can write in service, or servant girl, or servant boy, or servant woman, or servant Carl even. And then of course we have problems with spelling mistakes, negations, and so on. So you end up with a lot of work if you want to do it in this way. Our solution is that we use a fairly simple neural network. There's a lot of examples out there where people have already done this work. So we use existing data to teach a language model. We fine-tune one of the pre-existing ones out there. So imagine ChatGPT. This is like a ChatGPT just for HISCO codes. And of course the model that lives inside is not exactly the same, but it's of a similar nature. And then what we can do is that we can get a virtual assistant that can do this type of work for us. Here's an application. The Link Lives project, based at the Royal Archives in Copenhagen, they have published data for the so-called Copenhagen burial records. And they also contain the occupations of people who died, or the occupation of their parents. And in an afternoon, we were able to just apply our algorithm. This would have taken maybe a few weeks or a few months of manual labor, just adding HISCO codes to whatever we did here. But instead, it ended up taking just an afternoon, and we got, with 90% accuracy, HISCO codes for all the people buried in Copenhagen from around 1861 to 1911. And then you can do lots of different things with this. This is just a very simple plot, so you can see that around 60% of people buried in Copenhagen in this period, they had occupations with HISCO codes starting with 7, 8, or 9, and of course that's sort of technical, and you would have to know. But 7, 8, and 9 are people who work in manufacturing. So what we can say from this is just that Copenhagen in this period was filled with people who worked in manufacturing occupations. And then of course we can analyze the development, we can analyze the education, we can analyze why they died. There are tons of things which is suddenly readily available to do, which would otherwise not be as easily possible to do. So something that took weeks, months, years, now takes an afternoon. This enables new research, and it enables more time on caring about the quality of the sources and their nature, instead of spending time sweating in the archives. And of course I have to say, this is still a work in progress. This is what we're doing right now. We will have more results, more data, more training of our algorithm ahead of us. But I'm really excited to see where this heads.